In this video, we're going to take a look at understanding data types with Python. Probably one of the most crucial things as a programmer that you would need to understand is those data types. Yes, Python does declare data types for you, but you may need to convert or you may need to understand what data types are doing so you can get your code to do what you want it to do. All right, so every programming language has a set of standard data types. There are quite a few, and the ones most commonly used are the following. So we used strings last time. We said that's a combination of any numerical characters. If it's on the keyboard and you put multiple ones in a variable, you have a string data type. Now, Python 3 doesn't have a character data type. If you're coming from another language and you're trying to figure out how do I create a single character in Python, you simply create a string and you put it one character in length. Very important to know that. Integers are whole numbers. Anything without a decimal. -5, 0, 3, 4, any number, positive or negative. Floating point are numbers with a fractional part. This would be like for pi. 3.14, anything with a decimal, positive or negative. If you're coming from another language, Python 3 does not have a built-in double data type. Use the float data type instead. And then there are the Boolean data types. This holds the value true or false, usually done with a comparison operator, and we'll take a look at that today. One other thing we're going to look at is doing math with Python. There's going to be a lot of information here, but nothing we can't handle. So every language has math operations that can be performed. The Python has the plus symbol for addition. Now we also used that in the last video to concatenate strings. When we're doing math, we're still going to use the plus sign. The minus sign, that's for subtraction. The asterisk is for multiplication. If you're new to programming, we can't use X. That's going to be recognized as an undeclared variable. So we can't use X, we use the asterisk. Now, if you're coming from another language, you maybe have used the caret symbol, which is usually the shift 6 key for exponents. In Python 3, you cannot do that. You use the asterisk asterisk. So A asterisk asterisk B would be read as A to the power of B. So why can't you use the caret symbol? Because the caret symbol is for bitwise operations, and specifically the XOR bitwise operation. Now, if you're feeling overwhelmed at this point, do understand that bitwise operations are usually a little more advanced. You have to have a firm understanding of binary, but to get started with programming, you don't need to know bitwise operations right away. You can save those for a later day. We have a single division that results in a real number, so that means one with a decimal. Then we have two division signs. That's for floor division, which we're going to see today, always moving towards negative infinity. What does that mean? That means we're always going to be moving towards the negative infinity direction. So we're always going to be going down. We're not going to be going up. We'll take a look at that today so it makes sense. Then you have the percent sign. That's for modulus. So A modulus B is going to give the remainder of A divided by B. So if I do 4 modulus 3, that's going to give me the result of 1, because 3 goes into 4 one time. 4 minus 3 is 1. So it gives the remainder. Equal is for assigning a value. A double equal sign is checking equality. So the data is either equal or it isn't. It's true or it's false. All right, so let's swing over to Python. Let's become familiar with these data types and see them in action. So I created a new project in PyCharm. If you would like to, you can go over here, File, New Project, and you'll be able to call it whatever you want. I called mine Math and Data Types because that's what this deals with. All right, so let's start taking a look at why you need to understand data types. I'm going to create a variable called num, which is short for number. Now, I'm going to do input. I'm going to tell the user, please enter a number. Well, we're going to do that. Let's do some math with it. Let's do print, and let's do num times 5. We'll do that. So we'll do 10, and then we'll try to see if 50 is outputted. So I'm going to go ahead. I'm going to run my code. It says, please enter a number. I'm going to type in 10. And then when I hit enter, we should get 50, because 10 times 5 is 50. And we get 10, 10, 10, 10, 10. Well, that's certainly not what was expected. This is an example of why you need to understand data types. So let's check the data type of num, because our code's not doing what we want it to be. Anytime you need to check the data type of a variable or to see what you're getting, you're going to type in type, which checks the type, and then num. We want to see what is the data type. Why is it not coming out to 50? So we run our code, says enter a number. We're going to enter 10 again, and we get 10, 10, 10, 10, 10. So right here though, before it outputs that, it tells us it belongs to the class str. What does that mean? That means it's of the string data type. So when I do a string multiplied by a number, it's going to output that as many times. If I do 2, it's going to output it 2 times. That's very important. Well, that's not what we want to do. We want to do some math. So how do I get this num to become an integer? Well, if you're taking it directly from an input, you do it like this. You do int, which means you want it to be an integer. Then what we're going to do is, what do we want to be an integer? Whatever the user responds impart to this input. So now we're going to run our code again. We're going to type in 10 again, and this time it should come out to 20 because we're doing it multiplying by 2. And we get 20. It's of the class int, which means we're able to make it an integer. Guess you don't need that space there. You can if you want. So that is how you create an integer. Now, if I get rid of this int for a moment, I use the multiplication symbol for a specific reason, and that was because I knew what it was going to do. And it's important to show you an example of why you need to understand your data types. Now, let's say I tried to add a string with +2. That's not going to work because 2 is an integer. What about this? Will this work? Yes, because this is a character. It is a string with 1 character in it. So that will work because we can concatenate 2 strings together. If I tried to use subtraction, that would also give me an error. But once I put in the int, that error will go away. And this time, if I say enter 10 again, it'll give me 8 because 10 minus 2 is 8. So we can do that with any of them. I encourage you to work with plus, subtraction, multiplication, divide. Now, for the divide and divide for floor math, we're going to go ahead and we're going to do that right now. So what we're going to do is we're going to input the number 13. So we're going to do, actually, let's go ahead and run through these because then we can go through multiple scenarios. So we'll start with 13 divided by 2. That's going to give us an answer. Then what we're going to do is we're going to print, and the second time we're going to do 13 divided by 2 using floor multiplication. So I'm going to print out a bunch of these. Let's go ahead and fast forward to where all the scenarios are done so we can see how it works. So here's a scenario of where we're using division and floor division. So we have 13 divided by 2, 13 divided by 2 using floor division, using a floating number, 13.0 divided by 2, 13.0 floor division divided by 2, 13.0 divided by 2.0. We're going to run through all those to see if it makes a difference. Now, you need to understand when using floor division, we move towards negative infinity, and that is why I have these numbers here. So if you would like, you can pause the video and you can try to predict what these values were going to be, but one of the best ways to know is to run our program. So if you'd like to pause, go ahead and pause and predict the values. We're going to go ahead and run it. So here's what we got. The first one, 13 divided by 2, that comes out to 6.5. When you do the division, it's going to result in a real number. And remember, a real number or a floating point data type is one that has a fractional part, meaning it has a decimal value. Here, when we use floor division, we're moving towards negative infinity. Now, floor division moving towards negative infinity means we're not just dropping the decimal here. What is closer when we have 6.5? Is it going to be 6 or is it going to be 7? Which one is closer to negative infinity? Well, if you look on a number line, 6 is closer to negative infinity. So you're not going to get a decimal here. You're going to get an integer, but the one closest to negative infinity. So here we have a floating data type divided by an integer. Again, that will result in a floating data type, which is a real number, 6.5. What if we use floor division with a floating data type in an integer? Well, then we get 6.0. That decimal is there. If I didn't want the 0.0, I'd have to use a single division symbol. So here we have 13.0 divided by 2.0. That gives us 6.5. So it works the same way as 13 divided by 2. Then we have floor division, 13.0 divided by 2 using floor division. We get that 6.0 again. Now, here's something that is interesting, is when we do print negative 13 divided by 2.0, we get negative 6.5, which is the same thing. But what if I use floor division and do negative 13 and use floor division divided by 2? If we run our code again, you'll get something interesting. You'll notice that it comes out to negative 7, not negative 6. Why? Because when you're using floor division, you're moving towards negative infinity. Well, what's closer to negative infinity? Would that be negative 6 or would that be negative 7? Because negative 7 is closer to negative infinity. That's why you get negative 7 here. So what we're going to do now is we're going to take in two integers and we're going to check to see if they're equals for equality, so we can use Boolean data types as well as storing them, declaring them, and outputting them. So let's go ahead and switch over and do that. All right, so let's put some of these things together. Let's declare a Boolean value. I give it a name, check, and that can be true or it can be false. Now notice the T was capital and the F is capital. You cannot have a capital false or a capital F or a lowercase f in false, a lowercase t in true. Remember, Python is case sensitive. You can make it true or false, it makes no difference. So if you're asked to create a variable, that is how you do it, a variable that is of a Boolean data type. So we're going to ask for two numbers and store in two different integers. So I'm going to do num1. I'm going to set that equal to, I want an int, and then I'm going to use my input. And what am I going to ask? Enter number 1. So they're going to enter a number. Then I'm going to do the same thing for number 2. I'm going to say I want the int data type, and I'm going to input. I'm going to say enter number 2. And then I can do whatever I want. I can add those numbers together. I can subtract, divide them, whatever I would like to do. What we're looking at now is how do we compare them and store them in a Boolean variable. So I'm going to do check equals. That means I'm assigning a value. What am I assigning the value of? I want to see if num1 is equal to num2. Now you can do this with or without parentheses. I generally like to use parentheses because if I'm comparing multiple things, I want to make sure that it doesn't get out of order. Now you'll notice check is underlined. That's saying because we already gave it a value. If we didn't need to declare a variable, we could do it just like this. And here, it's going to make check a Boolean value because num1 equals nums2, checks to see if they're equal or not. Then we can simply output the Boolean variable. So we can output check, but we can also output it if we want without using a Boolean variable. I can put num1, num2 equals num2, and that will check to see if they're equal. So let's do this using two different values, and let's see how it works out. So enter number 1, I'll say 5. Number 2 is 10. Now check, we'll check to see if 5 and 10 are equal. That will be false. So we should see false and false when we enter 10. And we do, we see false and false. If we run it again, we need to make sure that we check that the numbers are equal and that it works the way we want it to. So I'm going to enter 10 and 10. We should see that check becomes true, and then it will print true twice because check will be true as well as num1 equals num2, and we can see that it works. Hope you guys found this video helpful. If you did, make sure to give it a thumbs up and subscribe to help the channel grow, and we'll see you guys in the next Python video.